Now let us discuss about the female reproductive part of a flower, that is gynoecium. So gynoecium in a flower may contain single carpel or it may contain more than one carpels. If a flower has got gynoecium with a single carpel, it is considered as monocarpellary. If a flower has more than one carpel in its gynoecium, then it is considered as multicarpellary. So based on the number of carpels present in a flower in its gynoecium, it may be considered as monocarpellary or multicarpellary. So carpel or pistil is the female reproductive organ of a flower. Gynoecium is a whorl, whereas each gynoecium consists of carpel or pistil. So pistil represents the female reproductive part, and each pistil has distinct parts. There are three distinct parts in a pistil. They are ovary, style and stigma. The ovary is usually placed on the thalamus. You know that thalamus is the swollen part of the pedicel. In the previous class we have discussed about the structure of a typical flower, where we have come across stalk-like structure known as pedicel and tip of the pedicel which is swollen to form thalamus. So on the thalamus, the pistil is located. The pistil has got three distinct parts. They are ovary, style and stigma. Ovary is the basal swollen part of a pistil. Above the ovary, there is long slender tubular structure known as style, and tip of the style has got a structure known as stigma. It is this stigma that forms the platform, that is the landing platform for the pollen grains to get deposited. So the tip of the stigma forms a platform where pollen grains get deposited and pollen germination takes place. Within the ovary, there is a cavity known as ovarian cavity, and inside the ovarian cavity, there is a cushion-like tissue known as placenta. Attached to the placenta, there may be one or many ovules. So, within the ovary, there is a cavity known as ovarian cavity. In the ovarian cavity, there is a soft cushion-like tissue. Attached to the cushion-like tissue, there are ovules. Ovules are the megasporangium, or ovule is considered as megasporangium. So here we have represented a single ovule, and these ovules are attached to the placenta with the help of a stalk known as funicle. So now let us discuss about the structure of a single ovule. So ovule is also known as megasporangium. Ovule is also known as megasporangium. Now let us discuss the structure of megasporangium or ovule. Ovule is usually attached to the placenta with the help of a stalk known as funicle. Okay, so here the ovule is represented in a inverted way. Okay, ovule is represented in a inverted way because in majority of the angiospermic plants, that is more than 90% of the angiospermic plants, its flower has got inverted ovule. Inverted ovule. Such a ovule where the ovule is inverted with respect to its stalk, that is funicle, is known as anatropous ovule. So ovule is a structure that is attached to the placenta with the help of a stalk known as funicle. Okay. Between the funicle as well as the ovule, the oval-shaped ovule as well as the stalk funicle is attached by a structure known as hilum. So hilum forms a point of attachment for funicle as well as ovule. So hilum forms a point of attachment for funicle with the ovule. Now the ovule is covered by two envelopes which is considered as integuments. The outer envelope is called outer integument. The inner envelope is called inner integument. So there are two protective envelopes or coverings around the ovule. They are outer integument and inner integument. If you observe the diagram clearly, the outer and inner integument do not cover the ovule completely. So if you observe the diagram, you can see that in one of the end, there is a small pore left behind by the integuments. So this small pore left behind by the integument, that is outer and inner integument, is known as micropipe. The small pore that is left behind by the integuments is called micropipe. So the end of the ovule which has got micropipe, that is towards the micropyle, the end of the ovule is called micropylar end. The opposite end of the ovule, that is opposite to micropylar end, is called chalazal pole or chalazal end. So the chalazal end or the chalaza forms the base of the ovule. You should remember that this ovule is an inverted ovule. So since the ovule is inverted, it is known as anatropous ovule. This is the stalk of the ovule. This is base of the ovule. So what is the base of the ovule known as? Base of the ovule that is called as chalaza. And end is known as chalazal end or chalazal pole. What is the opposite end of the ovule? It is known as micropylar end, and towards the micropylar end, the integuments do not cover the ovule. So a small pore is left behind, which is known as micropylar. So within the integuments, that is enclosed within the integument, the ovule is filled with nutritive tissue known as nucellus. Within the integuments, the ovule is enclosed within the nutritive filled tissue. So within the integuments, there is nutritive filled tissue known as nucellus. So among the nucellus, one of the nucellus cell towards the micropylar end, one of the nucellus cell towards the micropylar end develops into an embryo sac. Remember that not all the cells of the nucellus, only one of the cell towards the micropylar end later on develops into embryo sac. So embryo sac represents the female gametophyte of an angiosperm. What is embryo sac? Embryo sac is the female gametophyte of an angiosperm. So what do you mean by term gametophyte? Gametophyte is a plant body which produces gametes. So what type of gametes are formed inside this gametophyte? Female gametes are formed. So embryo sac is considered as female gametophyte of an angiosperm. And then what will be the male gametophyte of an angiosperm? Male gametophyte of an angiosperm is pollen grain. So this is very, very important. You have to remember this point, that pollen grain is the male gametophyte of an angiosperm, and embryo sac, which is found inside the ovule, is the female gametophyte of an angiosperm. So this diagram is also important from exam point of view. So this diagram can be asked for 5 marks. So do practice this diagrams as well as the labels, and whenever you are labeling the diagram, you should keep in mind that let all your labelings be towards one side. It will be better if it is towards the right side, and please do label the diagrams in an order in